Hey there. So today we are going to start a Wireshark course. Okay, so before that, let's discuss today's agenda. First, intro to Wireshark, and then installation process, and then important terms, which is basically related to networking. Because before getting into Wireshark, we need to understand some very important networking concepts. Okay, then Wireshark GUI interface, as there are two ways to interact with the system. First is GUI and second is CLI. GUI means graphical user interface, which lets a user to interact with the system or device with the help of graphical elements. Okay, like menus, icons, etc. On the other hand, we have CLI, means command line interface, which lets a user to interact with their system or device with the help of various commands. Okay, so some operating system provides their users with only CLI, while some provides with both GUI and CLI. Okay, next we will see important filters and then packet analysis, which is basically used to monitor and analyze network packets. Okay, and then we will discuss how it is dangerous to log in with your username and password on HTTP request. Okay, and then we will see Wireshark CLI interface, which is known as TShark. So basically, Wireshark is for GUI and TShark is for CLI. Okay, so what is Wireshark? Wireshark is an open source cross platform program or tool that is used to capture and analyze network traffic. Okay. It is the most popular tool and used in almost every domain like networking, digital forensics, cybersecurity, etc. So, Wireshark is an open source, which means we can modify its code or contribute to its source code, as well as it is free to use. So, there are certain types of software like freeware software that are free to use, but we cannot modify its source code. Then we have paid software, which is of course paid, but we have to buy it after using its trial version. Okay, so now you can find the source code of the Wireshark at this link. Okay, now and cross platform means it can be run at any platform like Windows, Linux, and Mac, etc. Okay, now the question arises: what is the need of using Wireshark? It's like why are we using such a complex tool? So the answer is simple: to analyze packets. Yeah, it's all about the data packets. But what is packet analysis used for? So packet analysis, also known as packet sniffing or packet analyzing, is used to intercept and capture live data as it travels over the network, like Ethernet or Wi-Fi. Okay, in order to understand what is happening in the network, I repeat, packet analyzing is the process which is also known as packet sniffing or packet analyzing, is used to intercept and capture live data as it travels over the network. Okay, like Ethernet or Wi-Fi. Okay, in order to understand what is happening in the network. Okay, so I think this much is clear to you all. Now let's move forward with the installation process. Now for Windows, open the browser and search for Wireshark download. Okay. Then go to the Wireshark's official site, wireshark.org, and then there you will see Windows installer 64-bit and 32-bit. Okay, then you can download it according to the need of your or architecture of your system. So, okay, for Fedora or Red Hat based Linux system, the command is yum search Wireshark. Okay, so open the machine, then open terminal here. Okay, and type yum search Wireshark. Okay, enter. And then there you will see the number of Wireshark versions. Okay, so for installation, yum install. Okay, sudo yum install Wireshark. Okay, I mean Wireshark version. So copy this and then paste it here. Then enter. Okay, then password. Okay, so this will install the Wireshark on your Red Hat. Okay, then I am terminating this because for this session we will use Debian based systems or OS. So now Debian based systems. So in Debian based systems like Kali Linux, PareToOS, Ubuntu, the Wireshark comes pre-installed in it. So but if you want to download it externally, so open your machine. The command is apt get install Wireshark. So open your machine. You can try this on any Debian based machine like Kali Linux, PareToOS, Ubuntu. But okay, so sudo apt-get install Wireshark. Enter. Password. Okay, so this is saying Wireshark is already the newest version, so we don't need to download it. Okay. So before starting the Wireshark, let's understand some important networking terms. So first we have IP address. IP address or Internet Protocol is a set of predefined rules under which communication shall be conducted. Means IP address in a sense were designed in order to make it possible for devices to communicate with each other over the internet. Okay, this is the primary purpose of an IP address. It can also be used to pinpoint your exact physical location of the device you are using it. So suppose just like you have your home address, which helps courier services to deliver your packages at your home or destination. Same is like with the IP address. It helps your system to recognize over the network or internet so that you can send and receive data packets at the correct location. Okay, it is a 32-bit address. There are 4 blocks, and each block contains 8 bits, and it can go from 0 to 255. For example, 192.168.0.12. Okay, is an IP address which is separated by a dot. So next we have ports. Computer ports are the entry points for all the information coming to our devices and all the packets that are being transmitted by them. Okay, they work in combination with IP addresses, directing all outgoing and incoming packets their proper places. Means networking ports are the virtual points where the network connection starts and ends. Ports are software based and managed by your OS operating system. Each port is associated with a specific process or services. Okay, and ports allow computers to easily differentiate between different kinds of traffic. Okay, and with each port assigned a number range between 0 to 1023. Okay, but the numbers can go higher than that. Most ports are reserved for certain reasons like FTP, DNS, SMTP, HTTP, etc. Okay, next we have DNS. DNS means domain name system. It resolves domain names to IP addresses and vice versa. For example, google.com. Like, for example, you want to search amazon.com. Now, which one is easier for you to search, amazon.com or an IP address like 205.251.242.103? So obviously amazon.com is easier to search. So DNS converts your IP address into domain name system and vice versa. Now next we have MAC address. MAC address stands for Media Access Control. It is a hardware address that uniquely identifies your network card, which is manufactured by the company. Okay, MAC address is also known as physical address or hardware address. So MAC address are 48 bits long. They have two hubs, like first 24 bits form the organizationally unique identifier OUI, and the last 24 bits forms a serial number, formally called an extension identifier. Okay, remember, MAC address uniquely identifies your system over LAN, local area network, and IP addresses uniquely identifies your system over the WAN, wide area network, means internet. So if you want to change your MAC address permanently, then you have to change your physical NIC card. But you can change your IP address easily with the VPN and proxy. Okay, now you can change your sniff your MAC address temporary with the help of various tools, but it can goes back to its original state when you reboot or restart your system. Okay, now protocols. Protocols is a set of predefined rules that determine how something should be done. Okay, protocols are agreed upon standardized ways of communication over the internet. Example, TCP/IP protocol means as establishing the connection and communicating over it is not enough. What is important is the proper communication. For example, now proper communication in the sense means to ensure that your packets are reaching at a right destination, they are not modified or tampered in the middle in any way, and they reached in order or sequence and contain no errors. So okay, now we have open OSI model, open system interconnected model, which is consist of 7 layers. OSI was developed by ISO. Okay, so it is now considered as an architectural model for the intercommunications. OSI model divides the whole task into 7 smaller and manageable layers, and each layer is assigned a particular task. Okay, so first we have physical layer, which is responsible for transporting signals over the network at electrical level. So it deals with cables, network cards, routers, etc. Okay. Next we have data link layer. Data link layer consists of encoding and decoding of data packets as they are translated into bits. Okay, it is also responsible for handling any errors that might have occurred in the physical layer conducting the flow control. Okay, it is made up of two sub layers, MAC addressing and LSA, logical link control. So MAC control permissions in terms of how a computer will gain access to data, and the permission to send the same, while on the other hand, LSA synchronizes frames and ensures flow control and conducts error checking. So at data link layer, your data becomes frames, and at network layer, it becomes packets. Okay, it is responsible for handling any errors that might have occurred in the physical layer. Now, how can the errors arises at the physical layer? There are many reasons that the error can occur, like when we transmit the data over long distances, the energy can lose during transmission, or attenuation can occur, or sometimes natural calamities like thunderbolt and lightning, or sometimes usage on end of your system, which causes sudden spark in the electrical board. So these things changes the binaries of the packets, as overall our data is in binaries from 0 and 1. So when the error occurs, your 0 becomes 1 and your 1 becomes 0. This is how data changes from its original form. Okay, so if one bit changes if one bit changes, then we can use single bit error check, and if more than one bits change, we can use burst error check. And CRC and error checksum is also used in error checking, detection and correction. Okay, now we have network layer. Network layer provides switching and routing. It creates virtual circuits. It is also in charge of addressing error control and packet sequencing. Okay, so network layer ensures host-to-host delivery with the help of logical address or IP address. It performs routing and it involves RIP and OSPF protocols. Like RIP stands for Routing Information Protocol, and OSPF stands for Open Shortest Path First Protocol. So, which is used to do the routing. At network layer, routers are so smart that they know where to forward the packets in the network by the help of routing algorithms. Okay, so it also performs fragmentation, means dividing your data into packets. Okay, now then we have transport layer. Transport layer transfer data from one host to another. Okay, it ensures error recovery. In short, it preserves the integrity of data. Integrity means your data has not been tampered in the middle in any way. Okay, so here lies TCP protocol, and it also guarantees the sequence of data, and the data is really used there. Okay, then we have session layer. Session layer coordinates communication between applications. It manages and terminates connection dealing with the sessions. So it deals with the sessions. Okay, then we have presentation layer. Presentation layer, it provides independence from difference in data representation. Simplify translated from application to network format, and the other way around. Means all it does is convert data into suitable form for the application layer to take it. It formats and encrypts your data for transmission also. Okay. Then we have application layer, which supports application running on your computers. It takes into consideration and authentication, which means the intended person is assessing the sources. Okay. Then privacy, and it also handles quality of services, provides services for all the manner of file transfers. And here lies HTTP protocols, HTTPS, FTP, and Telnet, and etc. and other network services. Okay, now let's discuss TCP versus UDP. TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. So TCP is a connection-oriented protocol, means before transmitting the real data, it established a connection by performing a three-way handshake. Okay, after that, it starts to transfer the data. While UDP is a connectionless protocol, means it directly starts to send packets without establishing a connection between sender and the receiver. Okay, then we have data sequencing. TCP is in short data sequencing, means data reached at a destination in the order way, while UDP unable to sequence the packets. Okay. Okay, then we have guaranteed delivery, which means TCP guarantees data delivery. And if one of the packet is missing at destination, TCP requests the sender to send back the packet again, while UDP cannot guarantees any delivery of data at destination. Okay, then we have retransmission of data. In TCP, retransmission of lost packet is possible, while no retransmission of lost data, lost packet in UDP. Okay, then we have error checking. Um, TCP performs error checking and acknowledgement of data, means sending the acknowledgement packet to the receiver that we have received your data. While in UDP, basic error checking mechanism like checksums. Okay, then speed, slower than UDP. TCP is slower than UDP because TCP has performs various functionalities like sequencing, error checking, acknowledgement, retransmission of data. So all this process takes time, and UDP is faster than TCP. Then we have optimal use like HTTPS, HTTP, SMTP, FTP, POP, all uses TCP. And video conferencing, streaming, DNS, UIP uses UDP. Okay, so enough theory. Let's move to the practical part. Okay, so to find the interface you are listening on, open your virtual machine. Okay, open your terminal and then type here ifconfig. Ifconfig is a command which will display all your network related details like your IP address, your MAC address, your broadcast IP, your netmask, and your interface's name. Okay, then enter. So here's my interface name, my IP. Okay, MAC address, broadcast IP, and then netmask. Okay. So if we have more than one interface, so all will display here. So I hope this much is clear to you. Okay, now let's get familiar with the Wireshark GUI interface. Okay, so open your machine. So open the terminal. Type sudo Wireshark, then password. Okay, this will open your Wireshark window. Then all your interfaces are listed here. Okay, then select interface. But before that, go to edit and then preferences. Okay. Now there you see appearances like main window, window size, and show up columns and other basic stuffs. Okay. Then you have columns. Okay, there you can add any number of columns you want with a type of value. Okay, same colors. Okay. Here you can change the font size and color of the elements and text displayed on the main window while capturing the packets. Okay. So you can this according to yourself. Then layout. Here you can choose your layout, the way you want to display or set pages. Okay. Then we have capture. Now there you can select the default interface so that every time you start your Wireshark, you don't need to select the interface again. Okay. So select it, default. Okay, then we have filter buttons. Now here you can create filters for different profiles on the Wireshark. Okay, then we have protocols. Okay, there are many. So you don't need to understand all the protocols, but understand the most important ones like HTTP, HTTPS, TCP, FTP, etc. Okay, and select your interface and start capturing. Okay, so now on the view tab, go to the view tab, and then there you will see zoom in, zoom out, expand, collapse, all the features, coloring, packet list, coloring rules, colorize conversion according to yourself. Okay, then go to packet, next packet, previous packet. Okay, you can do this from here also, like previous packet, next packet, specific packet, first packet, and go to last packet. Okay, and then colorize options, then zoom in, then zoom out. Okay, then fit on the main window, then stop button, and then restart and use a file. If you want to open the packet, then you can select, you can open it from here. Okay, so there's a filter option where you can apply your filters. Then go to analyze, display filters. All your default filters are displayed here. Then you have display filter expression that are applied with the filters. These are the default expressions. Okay. So apply as a filter, apply as a filter. So this is enough to get started with the Wireshark. Okay, now let's discuss important filters. Okay, filters are used to filter your traffic or packets. Okay, so we have some important filters like HTTP, TCP, UDP, DNS. Okay, let's try it. Open your browser. Sorry, Wireshark. And then open your browser to generate some traffic. Search for anything. Let's say fountains. Okay. So apply some filter. Let's say TCP. TCP stands for Transmission Control Protocol. So it will display all the TCP packets. Okay. So at bottom, here you see packets 1504 and displayed 81.5%. This will show the quantity of the packets in percentage. Okay. Then we have DNS. Okay, it will display all the DNS packets. Then we have HTTP. Okay. Then let's say ICMP. So we don't have any packets yet. Let's generate some. Let's say ping. Let's ping google.com. Enter. See. So our packet has been generated and displayed here. Okay. Then we have UDP port is equal to 53. Okay. So it shows all the traffic via UDP on port 53 means DNS. Okay. Then same with TCP. Okay, currently we don't have any packet, right? So UDP. See. Then next we have IP.source. Source in the sense RIP. So let's say the 92.168.129. Okay. So so it will shows all the packets flow in source IP. Then same as destination IP. DHT. Okay. Let's find the IP of this website. Open the terminal. Ping it. So IP of this website is so here's the IP. Okay. Let's find its packet. Copy it. And paste it here. Enter. So it will shows the packet flowing in source in destination IP. So it will shows the packet flowing the destination IP. Then we have the IP address. IP address. Okay. So it will shows the packet flowing in particular IP either on the source side or on the destination side. Enter. Okay. Okay, now let's see packet analysis. It is used to monitor your network packets. Okay, so open your Wireshark. Okay, let's say we have to analyze this packet. Then expand your bottom window. Okay. First we have frame. So it deals with the physical layer. Okay. Then we have Ethernet second. It shows you the source MAC address and destination MAC address. That's it. Then we have Internet Protocol, which shows the IP version, source IP and destination IP. Then we have the header LAN. So header means whenever we send the data through TCP, TCP adds the header along with the data because headers provide lots of functionalities like source IP, destination IP, and header LAN, etc. Then we have header length, then protocol, TCP, okay, then source address and destination address, okay. Now we have transmission control protocol, which shows you the source port on which we are transmitting our information towards the destination port. These ports are randomly generated via machines and they can be of any number at any given range. And then we have the destination ports. Okay, then acknowledgement number. Then window size. Window size means how much a receiver can receive a data at a time. Okay. Then we have checksums. Okay, now that's it. This is all about the GUI interface, and I think it is enough for getting started with the Wireshark. Okay, now let's see how it is dangerous to log in with your username and password on HTTP request. Okay, so what is the difference between HTTP and HTTPS? HTTPS uses SSL certificate to encrypt your normal HTTP request and responses. Means in HTTPS, S stands for SSL certificate, which encrypts your HTTP request and responses. Okay, so overall HTTPS is far more secure than HTTP. Okay, let's see it. Open your machine and open your terminal. Type here sudo Wireshark. Open your Wireshark. Okay, select your interface and then minimize it. On the other hand, open your browser. Okay, search here. Test login web page. Okay, enter. So wait a minute. Search HTTP login web page. Okay, then go on the first link. Test PHP. Okay, so username and password. So type here username. Let's say admin and password 12345. Okay, and click on login. Okay, now let's find the IP of this website. Think, enter. So here's the IP of this website, so that we can use it in our filters. Then open the Wireshark and apply filters. So this is the destination IP. So type IP.tst is equal to and IP. Okay, and HTTP. Okay, enter. So here you see number of packets. We have 5 packets and we'll select user info.php. Double click and then append the last HTML form URL encoded. So here you see uname admin and password 12345. So these username and password are in plain text. So this is why it is dangerous to log in with username and password on HTTP request. Okay. Okay, let's see another example. Minimize it. Okay. Click on second link, demo.t3framework.org. Okay. This is also a HTTP site. Type username, okay, admin, and password 124. Okay. And then login. Okay. Then let's find the IP of this website. Clear the screen. And then think. Okay, enter. So here's the IP. Then open your Wireshark. Okay, change the IP. Okay, and enter. So, okay, here are many packets. Let's find ours. Okay, click on this index.php. Okay, and then, okay, process it. Then second one. Okay, so see here's your username and password. Admin and 1224. Okay, now I hope this message is clear to you. Okay, now let's see Wireshark CLI interface. Because not all environments supports GUI Wireshark. So we have to work or get familiar with the CLI version. Okay, so open the terminal. Open your machine and the terminal. Okay, type TShark hyphen help. TShark for Wireshark CLI version. Okay, enter. So help command shows you all the arguments that you can use with the TShark command. Okay, I for interface, F for capture filter. Okay, and so on. Okay, now clear the screen. Okay, so first to show all interfaces. Okay. The command will be tshark -d. This will shows all the interfaces in your system. Okay, let's see it. tshark -d. This will list all the interfaces. Okay. Now, next is start capturing. For this, tshark-i. I stand for interface. -i. And then the name of the interface. Okay, let's see. tshark -i interface and name and number of the interface. Let's say 1. Okay, enter it. Okay, permission denied. Use sudo for it. Password. Okay, so it start the capturing process on ENS33 interface. Okay, I hope this is clear to you all. You can use the number or name of the interface. Okay, then clear the screen and then now if you want to capture the packets on multiple interfaces. Okay, then command tshark, use tshark -i 1 interface number or name -i interface number 1 and 2. Okay, let's see it. No. So tshark -d and then sudo tshark-i for 1 and -i for 2. Okay, it will capture the packet on interface 1 and 2. Okay, so capturing on ENS33 and NE. Okay, let's run it again. Okay. Let's generate some packets. Okay, no need. So I hope this much is clear. Then next is if you want to save a file, like if you want to save this output to a certain file. Okay, then okay, to save a file. For that, tshark -i interface name or number 1 -w. Okay, any path of the file. Path of the file where you want to save the file. Okay, and let's try. Clear the screen. Use sudo tshark -i interface name -w. Then temp. I'm saving it in temp directory. Okay, temp and the name of the file. File.pcap. Okay, pcap is the extension of the Wireshark. Okay. Enter. So it will count the numbers or show the numbers of the packets. Okay. Let's generate some packets. Mhm. Okay, see. So now let's open this file.pcap into our Wireshark. File, open, and then move to your directory and then select your file.pkf, open it. Okay, so here the packet. Okay, I hope this much is clear. Then, so now if you want to stop the capturing after a particular period of time automatically, so the command is to stop capturing TShark -I. You can do this with the help of -a command. A for auto stop argument. Okay, -a, then duration. Duration takes the argument in seconds. So 10 seconds, then -w for the path, save the file, and then file name. Okay, let's try. Let's say TShark-I. File name. Okay. Put sudo, enter. So this will stop the capturing after 10 seconds and save into a file. Okay, let's try with 20 seconds. Okay, this will stop the capturing after 20 seconds. Now next, we want to split capturing into different files according to the size of the file. For example, like for this you have to type TShark-I interface name, then -v for the file size to specify the file size. Okay, let's suppose 5 KB per s. Okay, then -a for the auto stop argument, then files. Okay, so it will split the files into 3 parts, and then let's save the file. Okay, let's try in a terminal. TShark-I before put sudo, then -v file size, let's say 5 KB per s, then -a files 3, and then -w 10, then file let's say 5 folder begin. Okay, before that, open another terminal and type temp directory near the city and type watch -n1 and then the command ls ltr. Okay, So this command will show live update of the directory when new files keep on adding in the terminal. Okay. Then keep them aside. Enter. Then enter. Okay, now let's generate some packets. Okay. See, first is generated file 4, then file 4, file 1, file 2. Now it will generate file 3. So now capture filters and display filters. Capture filters apply when you want to capture the specific amount of packets so that you won't run out of space. Because this is the common problem that you can run out of space when capturing a web server or a large organization packets. So and display filters apply when you want to display the specific packets but capture all packets. Okay. So now let's see to capture the specific filters. Okay. Okay. So capture the specific filter. Type TShark -I interface name again. Then -F F for filters. Then filter for okay. Now let's see in the terminal. Type TShark. Okay. Sudo TShark -I 1. Then -F. Then open. And then hit enter. Then you can apply as many as filter as you want. Okay. So first port 80, then enter or enter. Port 443, then enter. So it will capture the packets which are on the port 80 and 443. Means HTTP and HTTP. So next. So you can also run with a second set of interface. For example, sudo tshark -I interface name. Okay. Then -I another interface 2, and then -F for filters, and then enter. Now port 80 or port 443, enter. So it is capturing the packet on ENS33 and NE, which are on the port 80 and 443. Now let's say you want to filter the output file to see the specific results. Okay, so to filter the output file to see the specific results. Okay, and type tshark -R for read, path and name of the file. Okay, then -D, then -E, -D for to apply fields, and then -E to apply which fields. Okay, IP, suppose IP grep unit. Okay, let's try this. Clear the screen. Okay, CD temp where we have all our files. Then tshark. Okay, before that ls. Okay, suppose we want to filter out this file. Okay, then TShark -r, then file name, say file 41, okay. Then hyphen capital T, reads hyphen E, IP, grep, unique. My bad. Sudo. So it will display all the source and destination IP, which are unique in nature. Okay. If you want to only display the source IP, then IP dot source. Enter. Okay. Or if you want to display the destination IP, then destination IP. DST.